Thank you for joining us. I'd like to invite our panelists up on the stage. First, we have Jean-Claude Bergelman, Dr. Ryan Dooley, and Dr. Ann Bowser joining us for this afternoon's panel on open science infrastructure in the US and EU. And first, I'd like to do some introductions. Today, our panelists are here to explore and discuss the infrastructure, the tools we use to create, share, and assess scholarly work to support open science activities. And so first, I'd like to introduce our first panelist, Jean-Claude Berg.
It was also done this morning, you know.
Oh no, I did not. Well, Dr. Jean-Claude Bergelman, who is the head of Unit C2 DG Research and Innovation with the European Commission. He has been there for nearly 20 years and first started as a visiting scientist at the Joint Research Center. He then became the head of the Information Society Unit and moved on to the Bureau of European Policy Advisors as an advisor for innovation policy. He was previously a professor of communication technology policy at the Free University of Brussels and the director of the Center for Studies on Media, Information, and Telecommunication. And he has also been a visiting professor at the University of Antwerp, the European College of Bruges, and the University of South Africa, and also sits on several academic journals. So thank you very much, Jean-Claude, for being with us. I'd also like to introduce Dr. Ryan Dooley, who is a research associate at the University of Texas. He is manager of Web and Cloud Services Group, a group of technological blacksmiths tasked with evaluating bleeding-edge technology to build solutions that bring HPC and big data analytics to the web. He also has one of the the funnier bios I've ever read, and he hopes his work can someday edge out dancing teddy bears and waterproof mascara on their list of favorite inventions. So he is also the principal investigator at the Agave project, a science-as-service AP platform, allowing researchers worldwide to manage data, run code, collaborate freely, and integrate their science anywhere. He has a PhD in computer science from Louisiana State University, among several other degrees. And his research pulls together areas of distributing computing, data informatics, security and information modeling to craft innovative and engaging experiences for researchers in all domains. And his work has aided researchers over 5 continents. And last but not least, I'd like to introduce Dr. Ann Bowser, who is the Wilson Center's very own Director of Innovation. Her work focuses on understanding and mobilizing public participation in science, technology, and policy, and helps the Wilson Center leverage technologically innovative programming to reach new audiences. Ann's research focuses on topics including how technological interfaces can be designed to motivate participation, the role of standards and interoperability, and how citizen science technologies are appropriated from one context for use in another. She has her PhD from the University of Maryland's iSchool, and there she explored cooperative approach to designing fluorocaching, a geocaching mobile app for biodiversity data collection. So thank you very much to our panels, and we'll get started first with Jean-Claude. Thank you.
Okay. So thanks God I don't talk 3 times, because otherwise you have to hear it 3 times this year. So sorry for that, and also sorry you have to listen to me again, but the point is we cannot fly in too many people from Brussels for political, economical reasons. So I will pretend I know this as well as I pretended this morning. So again, it is a snapshot overview of the work we have been doing on the European Open Science Cloud, which was a pretty intensive piece of work we done with many people in Brussels from across the Commission, even more people from outside the European Commission, and a lot of friends and family. And again, Barend, who is sitting there, was one of our key persons in realizing this. So it's a huge task that is coming to to an end, so to speak, in the symbolical way at the 23rd of November, when we will launch the European Open Science Cloud as a reality. But of course, which will not be the end of providing a space for open data science in Europe, because that's what the European Open Science Cloud will do, because it's only the beginning of a process which will take years to settle down, to stabilize, and so on. So let me give you a little bit of what I think are the most interesting issues for this audience, and given the time forward. So it's a political opportunity. It was a decision, a political decision that our commissioner took. That, as I said this morning, that by 2020 we want to have all this data being made available in a service cloud, in the service called Science Cloud. And in order to be there, we had to advance a little bit the delivery date, as I said, 23 November of this year. So it will be a big event under the Austrian presidency. It will be a Vienna event. How do they invent it, all these things? But it will. You will certainly see it in the, at least in the specialized press and the tweets and so on. The idea behind the cloud is that simple. So when we worked on this, you have actually three scenarios: business as usual. You have a fragmentation of services, repositories, data providers, and so on, and they just go on, and you hope that magically at some point in time they will converge in a unified approach to open data. The second option is, well, you know what? We create our own cloud system, a huge server somewhere in the center of Brussels or in an associated country, and then you put on top of it dozens of civil servants to manage it. So that was also not an option. The third option, which is the one which you see there, it's in a nice picture. Everything that exists, all these players, hundreds of them. We have 2,000 repositories alone in Europe. So all these services, we federate them, and it is the federation which we call the European Open Science Cloud. So you federate the access, the protocols, the language, if you want, of how all these data can navigate, how they will be stored, and the federation is actually the Science Cloud. And it is an image that Barend uses a lot. So what we are trying to do is to create the internet of fair data. It's exactly the same. So no centralized authority, no centralization of the data, no centralized hosting, a distributed federation of everything that exists, but in a common language. Yeah? So that this is usable for everyone, and in order to have that common language, you need to have a common data approach, and that is where the fair data comes in. As I said, this is the Grand Place in Brussels. By the way, I'm from Belgium, the most beautiful Grand Place of the whole world, of course. I was born not too far away from that, and I live at the church at the end there, but that's, of course, completely beside the point. But the cloud, so this whole cloud was not made in Brussels. It is not something we invented. It came up. I know exactly when it came up, and I even know by whom it came up, and I know the date. It was in a meeting in 2014. René and I, we did in Leuven, where we brought the research community together. So all researchers from all kinds of fields in order to discuss the transitions of open science. And at some point in time, one of the bioengineers of Leuven told us, okay, this is all fine, all this open data, we need it, but how are we going to govern it? And how will it be made accessible across Europe? And then talking on this, we said, well, you know what, what we need is actually a science cloud. And that's where the idea emerged. So again, this is really important that it is an idea from the field, and that explains why we got so much traction in the stakeholder community. They came immediately there to support it, to do some of the work on fleshing out the details. So it is not invented in Brussels syndrome. That is the syndrome. So it is not that syndrome. It is a stakeholder-driven project, where we had a lot of, well, you know, this is the classical thing of doing policy. Yeah? So you bring them all together in a summit, you make them so that all the key players are there in one room, you make them signing up to a kind of a declaration. Do you commit ourselves to having open data, to create a research data management culture, to make sure that the necessary funds are there? That was the beginning of it. So 2016 decision, 2017 the first summit, bringing them all together in Brussels. At that day, it was the most tweeted event in Brussels, by the way. 1 year later, so that happened actually a few days ago, we had a follow-up summit where, again, even more successful as the first one, everyone restated their commitments. We have a list of 36 commitments that are attributed according to the stakeholders, what they will do as a kind of an asset which they bring in the Science Cloud. And again, a quite successful meeting. And that's the whole, if that table would fall dead, then most of DG Research, the top people are dead. So this is the top of our institution sitting there, which was not there, by the way, last year. So it also shows you the bureaucratic traction we have. Okay, now if you go into what is then in the end the cloud, well, the cloud, as I said, it is a service. It's a federating service. But of course, a service federates, it doesn't happen by magic. You need to have a model, you need to have components of it. And the key components on which there is work going on at all levels, in various degrees of where the Commission is involved, are there. This is, in a certain sense, the key elements of the Science Cloud. So the architecture by which the Federation can work, the data plans by which the data will be usable, and that's where the FAIR across Europe and across disciplines. So that's the FAIR principles which are put forward there. That's the only way at the level of principles that we can get to a kind of a seamless data space, research data space in Europe. Of course, all these principles have to be listed and outlaid and made operational. And then after this summer, we will propose a FAIR data management plan where all these components are detailed. Then there is a third block of the cloud, is the European Open Science Cloud, is what are the services that will be made available for the scientists in order to make use of all these data, and what kind of certification do you need to have there? And there are lots of projects on this. So it's called the EOSC Hub, where all these services are pooled in a certain sense. Then there is the block access and interface, and what kind of conditions and what kind of trajectories have to be followed there. I would say block A to D is relatively technical, if not exclusively technical, and relatively easy to find a solution, all things taken into account. When it becomes a bit more complex, and where as a policymaker we step in, is the rules of engagement, the rules of participation and engagement. On what conditions can who take part of this Science Cloud and with what kind of results. And the most complex thing was the governance. The last block of it, how will this system be governed, was the most difficult nut to crack. And I'm not still 100% sure it will be without any problem. And that is exactly what we will launch at the end of the year. So the governance structure will be launched at the end of the year. I'll come back to that in a second. So these are the building blocks of the Science Cloud, where all these stakeholder groups and people who committed themselves are working on, and where our role as Commission was mainly to facilitate the discussion and to take the initiative for rules and governance. This is a slide that I found on this, what I said this morning, the cost of not having fair data. So this is the total volume of research, the expenditure on European R&D, and then if you zoom that out, the cost of not having fair data is 10.2 billion, and the breakdown there is according to the different parts of the framework program. Anyway, doesn't matter, but it shows you, it's a slide we always use to justify, or not to justify, but to put an extra argument for the Science Cloud. If I then do, so there are 2-3 people here who can tell you all the details of the more technical part of the cloud. Let me focus on the governance, the guiding principles of what are we setting forward in terms of milestones. So it will be a two-phased approach, starting at the end of the year, and as a kind of a beta version, and leading to to a final launch in 2020. So there are all kind of provisions being made to make that possible. There is money set aside and a whole construction. But the key idea is launching the governance structure and then going for a separate institutional setup by 2020, where most likely, but this is my personal view, so don't quote me on that, except if you say it is personal, where most likely it will become a kind of an economic interest group or a cooperative, where all the players will bring in their assets as a mutualization mechanism of what all these infrastructures do. The guiding principles, well, they are there, so that's it is self-explanatory. So, but most important, 2 phases: beta version now, final version 2020. This is a typical European response to a governance structure, as you can see. So it is. It was quite fun to do. Well, to try to find a governance structure where everyone feels part of it, because that's the point, of course. Don't forget, you have hundreds of stakeholders who want to be part of it, and you have 28 member states who also want to be part of it. And then you triangulate that and you see the complexity. So what we came up with is a 3-layer kind of structure. At the lowest level, if you want the stakeholder forum, this is anyone who signs up with the declaration, the thing I mentioned 4 slides ago, can sit in the stakeholder forum so that no one feels excluded. It's very important. It doesn't go out of hand. Up till now, we have 140 big organizations relatively, but it gives Europe, it gives anyone the feeling that they are taken serious. At the higher level, but presented at the highest level here for political reasons, is the EOSC board, which are the member states plus the Commission. And they are having, let's see the helicopter view on how it works. But then at the highest level, but presented here in the middle, will be the executive board, 12 to 15 people maximum, who will be fully in charge of making it happen. And supported by, so we have set aside resources to support the management structure. We have set aside resources to allow them to work via working groups. It's a little bit like the Internet Society, if you want. You will have, on all difficult topics, you create a working group, and then there you go, and you advise the governance structure. The financing, the technical financing of connecting the nuts and bolts are being taken care of by the provisions that you see there in the next 2 years. So normally this will be enough to make the whole system take off, plus also the management support. And then in the second phase, 2020, bearing in mind what I said this morning, that in the meantime all funders in Europe agree on open data standards, we assume that it will be a zero-sum activity in terms of extra financing needed, because there will be so much money coming on the table in terms of having to make data openly available in a fair format, that the system can be self-supportive and most likely via spin-offs create its own revenue. So that is in a nutshell a little bit what the Open Science Cloud is all about. The most important thing is it is a process more than an institution. It's a process of federation, of creating a common language. It is supported by the Commission, but as soon as it works, it will be owned and run by the stakeholders, and the Commission will do what it has to do, is to retreat and take one seat in one of the boards, and then the system should govern itself. Hence, as Barend says all the time, it is the internet of, it's a bit like how the internet of works, and in this case, the internet of fair data. Thank you.
Thank you very much, Jean-Claude. Next, we have Dr. Ryan Dooley. Thank you.
Can you see?
Great. Oh, clicker. Let's see which one it was. Okay, great. So my name is Ryan Dooley. I work at the Texas Advanced Computing Center, which is a large compute facility at the University of Texas in Austin. So I'm going to tell you a little bit about Agave here. If you guys have never heard about Agave before, you can liken it to Jean-Claude's talk. He said kind of the first 4 areas of the Open Science Cloud were largely technical, and they find easy solutions for them. Agave is an easy solution, right? So it kind of takes care of those first 4 layers for you. And when people look at it, we say that it focuses on helping people manage their data, run their code, collaborate with each other pretty much however they want to, and then connect to everything from your phones to your fridge to the internet of me. Being a platform, it does that a lot of different ways, supports a lot of different things, everything from your standalone file copies to your cloud services to the favorite applications you use to publish your pictures and share those online. It knows how to run your codes, whether they're some very, very large hurricane simulation that's running when a new storm brews up in the Gulf of Mexico to machine learning that kicks off every time you log into your university email address. It knows how to interact with those and keep track of everything, so it gives you full reproducibility behind everything you do. Helps you collaborate using a lot of different protocols. How many people in here knew that Slack was down most of today? Yeah, well, close your laptops. You don't need to look at those now. I imagine email's still working, so some of you guys aren't looking up. That's fine. But Agave understands how to talk to all those things, right? So you can collaborate with the people you care about in ways that they like to collaborate. And then helps you connect to all kinds of things. I used to have a demo where I stand up here and I'd kick off some cool things that were tied into lights and tied into cars and appliances and things in the building that I was demoing. And people got tired of everything kind of beeping and buzzing all at once. But it was a neat demo, but the point is that it integrates with pretty much everything around you, from Alexa to your phone. So it does all this using web protocols that are very familiar to people, whether it be WebSockets or JSON APIs and JSON LD, using security mechanisms that are very common to developers. And I understand we don't have a big tech crowd in here, so I'm going to kind of wave my hands at a lot of this, which is fine because it does all of this as a cloud service. So to most people, what Agave does is save them a lot of time and a lot of money when they're building their applications, so that they focus more on the science rather than the technology, right? And a lot of people just think it's magic, right? And that's totally fine by me, right? Magic is a good thing, and it's very, very helpful because when you look out at the landscape today, if you are in a position where you have to put together the basic building blocks of a scientific platform, where you're trying to bootstrap a community of people to enable them to do things that haven't been done before, you need to really understand what's available to you. And when you look out there, you look at all of the different technologies, and this is maybe a tenth of the icons that will come up in a Google search when you start looking at what your options are. It can be overwhelming, right? You can be sitting there like this kid, just blown away. Oh my gosh, I didn't know all that stuff was there, right? And that's not where you want to be when you have a 9-figure project that you're on the hook to deliver. So people turn and they start building things like APIs. You'll hear a lot about APIs and REST and web services and things like that, especially when you talk about these large integration projects. And the reason you hear about that is because that's where people have turned. In lieu of trying to understand all the different technologies out there, they're just building APIs to kind of blend all of this stuff together. And that's just for the back end, right? There's actually a term out there for people that are trying to build the user interfaces and the application interfaces and the mobile interfaces to sit in front of all the technology that makes this research possible. And they say JavaScript fatigue, right? And that's a very real thing. People get burnt out just learning about the technology that's out there. So in the time this talk is going to last, I think like 12 new JavaScript frameworks were released. So it just keeps accelerating. So most of what Agave does, and most of my time, is really spent building bridges between technologies that maybe have been in place for a very, very long time, like you'll find across the EU and like you'll find in the US, that are underpinning most of the projects that are driving open science research today, and technologies that the commercial market and the open source market is using, like the commercial clouds on AWS, like Google, like Kubernetes and Mesos, and some of the other buzzwords that you're gonna hear about over the coming year. And my apologies to Jean-Claude, we don't have a bridge from Brussels, although maybe you can help me find one. But we do work globally with a lot of people, helping them integrate into their existing infrastructure, because what the end users are using for, or what the end users are looking for, really is cheat codes. If you have any people in here that recognize this was one of the old cheat codes for the Konami video games, right? Back when you had the original Nintendo Entertainment System, right? And you'd put that in, and instantly you'd become invincible, or you'd go right to the final stage of the game and you could win. Boom. right off the bat. And that's a powerful thing, right? That's a powerful analogy because this is what the researchers are looking for when they're actually trying to build out their technology and get their science done. Because we can't take our eyes off the fact that the researchers care less about technology and more about their science. So whatever we can do to accelerate the time from proposal to production, we're benefiting everybody, right? So, and that's kind of a form of magic as well. Right? So that's the Agave platform in short, and thank you very much for your time.
Thank you very much, Ryan. Next, we'll have Dr. Ann Bowser.
All right, let's get oriented. There we are. Good afternoon. So I'm primarily organizing this event, but as Steph noted, my personal research is in areas including citizen science, open data, and biodiversity. So when we lost the panelists at the last minute, I was happy to hop in and share a few of my thoughts on open biodiversity infrastructure. One thing I've become very aware of working in this space is the need for clear definitions and consensus around them. So according to Merriam-Webster, infrastructure is the physical and organizational structures and facilities needed for the operation of a society or an enterprise. When we talk about infrastructure in open science, we're commonly referencing the physical or digital components of things like clouds, but I actually think that this definition is really helpful too. For example, the European Commission Joint Research Center, just to illustrate this point, has opened its facilities to researchers around the world who contribute to Horizon 2020 calls. And this is as much about opening the organizational aspects of JRC, including access to researchers as humans, as it is about opening the facility itself. And so with this in mind, open biodiversity research infrastructure is all of the physical, digital, and organizational structures needed for people to understand biodiversity on a global scale. A couple areas of this that I'd like to highlight: the importance of data standards as infrastructure, raw and aggregate data and host portals, unifying frameworks, and then also networks of capable people who can use all of the above. And I wanted to speak about biodiversity because we have a really stunning example of open science infrastructure in GBIF, which is the Global Biodiversity Information Facility. This is an international network as well as a traditional research infrastructure, and it's funded by many of the world's governments, including European member states, the United States, and Canada. And it's huge. It's big. I think we'll hit 1 billion. This is a yearly count, so what is it, June? So probably maybe 2 billion by the end of the year. And it's also part of a larger information sharing ecosystem. I actually did the diagram in the upper right-hand corner when I was a PhD student back in 2012, using social network analysis software to figure out how different biodiversity data repositories were sharing data. And you see GBIF as the purple node, a really primary node in the network. But this also shows how we're not just talking about one infrastructure, but we're talking about many infrastructures that are linked. So this goes back to my idea of infrastructure as broader than just digital. Data standards are really important. And in GBIF, EML, which is Ecological Markup Language, and Darwin Core are the relevant data standards here. Anyone who puts data into GBIF has to use these. And that's big data that's actually supported over 50 peer-reviewed publications in 2017 alone. And these are publications that are written by people who aren't the initial data collectors. So this is illustrating how GBIF is helping science scale and supporting some of the efficiency goals that we heard about earlier. It aligns with a unifying framework such as the Aichi targets, biodiversity targets set by the Convention for Biological Diversity in the UN, and then also the Sustainable Development Goals. And it's linked to networks of capable people and actually takes capacity building as a primary goal. So the screenshot on the right is a very poor snippet of something called the Integrative Publishing Toolkit, which is essentially a set of workflows that helps people put their information into GBIF. And they also hold workshops around the world, especially in data poor areas, to teach people how to use GBIF and how to collect biodiversity observations in general. Your first fun fact about GBIF data: over 60% of it comes from citizen science. So eBird, which is a global project, is actually the #1 contributor of biodiversity data to GBIF of any type of project, whether professional or citizen science driven. Another example of citizen science data in GBIF is from the 100 BioBlitzes that the U.S. National Park Service hosted as part of their centennial celebration. And these were collected through the iNaturalist data collection platform, which is another infrastructure. And all research-grade observations were fed from iNaturalist into GBIF. Your second fun fact about GBIF. It is international, but it also isn't really. So this shows some major data gaps in Africa and Asia in the upper right-hand corner. But then also what I think is interesting about this slide is the discrepancy in where the data is coming from and who's accessing it. So out of those top 10 data publishers, 9 of them are in the United States or in Europe. And then on the right-hand side, when we start looking at data download requests, you only have 2.5 European or American countries. And everyone else is coming from Asia, particularly China and India, as disproportionate geographic areas that are taking a lot more data than they're contributing. Why does this work? Why do I think that this is an exemplar? Well, the data standards piece is huge. It's essentially a Trojan horse to interoperability that trickles down to the individual researchers. So if you want to be able to share your information and take advantage of this database, then you need to use the standards that the community have already agreed are the right ones. As I said, it's a powerhouse of a digital infrastructure, and it aligns really well with the unifying frameworks, so much that the United Nations actually uses species occurrence data in GBIF as one metric or indicator of our success towards hitting the Aichi targets around biodiversity data. And it also connects networks of capable people really well, in part by the distributed geographic reach of this infrastructure network, and also because it's part of this larger ecosystem. So because of the central node that GBIF has in this information sharing network, their practices actually spin out and are adopted by others in the larger research community. What are the limitations? Well, it's big biodiversity data, but it's also very narrow and it's very incomplete. So biodiversity is one type of science, and even within biodiversity, GBIF only collects information on individual species right now. So that's, did I see a cicada in my backyard? There's no information on, for example, population dynamics or genetic diversity between cicadas, which is a huge limitation. There's also gaps in terms of the actual information that comes in. We know that researchers who collect information are only sharing a subset of it with open databases such as GBIF, and this is for a number of reasons, including cultural barriers to data sharing, wanting to keep your research on your desktop so you can publish lots of papers on it. There are significant legal interoperability constraints, or actually there were, that's what that asterisk is there for. A paper that was published in 2018 based on research conducted in 2015 and 2016, an interesting finding in itself, found that only 11% of all GBIF databases have clear licensing. And the rest either had no effective license at all or had free text like, you may use my data if you email me. Another weakness is around provenance and reconsent. A related thing is attribution. There are no mechanisms in place for enforcing things like attribution requirements, even if an open data license is there. And I think a fourth major limitation is community capacity. I have a friend who has his PhD and his postdoc from Yale. He does his research on species in ecology, and I asked him, Adam, is your data in GBIF? And he says, no, I don't know how, so it's in a spreadsheet on my desk, but I will give it to anyone who asks for it. Well, they can't find it, and I think this problem is probably even more significant outside of Yale and outside of the United States and Europe. A couple cool solutions or workarounds that GBIF has pioneered. So I mentioned the paper that was published in 2018 on 2016 research. In August of 2016, GBIF actually implemented what I would call the sledgehammer approach to legal interoperability. They emailed all of their data providers and said, you now must pick between one of 3 licenses. You can do a CC public domain, which essentially waives copyright. You can do CC attribution, which says that anyone can use your data as long as they thank you for it. Or you can have a CC non-commercial use. And if you don't like any of these licenses, then pull your data from GBIF. What percentage of people do you think pulled their data? Okay, 0 and 5 would be great, but 7.5 is the actual answer. And I personally think that's pretty encouraging as well. And in addition to not losing as much data as they anticipated, the GBIF board actually thought this was a pretty risky move. 50% of all data providers actually chose to waive copyright entirely. So this is something that I would call as a policy solution. We think of policy solutions as public policy, but data policies are also an important aspect of policy that are often overlooked. There are also technical solutions to improving openness and access. This is the cicada example. I love cicadas. They're my favorite insect. Right now, documentation of a data set about cicadas is done on the level of the entire data set, so you can only license that data set as a whole. But something that GBIF is considering is moving to record-level documentation. So the bug in the upper right-hand corner of the screen could actually have a different data license than the bug in the middle of the screen. And this also helps address some of the provenance problem, because you can then attribute these individual observations to individuals as well as data aggregators. And in some cases, like in citizen science, you can also ask people to reconsent for their data to be used in different contexts if certain licenses and restrictions are actually desirable. What are the takeaways of this presentation? First, as writing this, I realized that citizen science and open science are inherently linked. Open data is a goal of both. Both have common goals and rationales for being taken up as policy priorities, and both also face similar policy challenges such as privacy. Second takeaway, technology can solve many problems. We heard blockchain mentioned earlier. I think blockchain coupled with a record-level documentation system could go a long way to addressing things like privacy, reconsent, and meaningful attribution. But the remaining problems are people problems. Legal barriers remain, also policy barriers. We heard about GDPR, and there's, I think, public awareness or researcher awareness of whether or not these are actual issues here is as important as the barriers themselves. The cultural barriers of our antiquated academic reward system certainly needs some work, and then capacity in the research community. I made a joke once that was very poorly received. That was, you need a PhD in biodiversity informatics to put your data in GBIF, and I still stand by that. And then finally, my fourth key takeaway, open science is international. We see this really strongly in biodiversity. We need the most data from the places that offer the least data, but there's a global need for this information.
Thank you very much, Anne. So now it looks like we have about 13 minutes left for questions, and I'd like to ask the first one, and then I will go to the audience for some questions. So my first question to our panelists is, and I think each of you touched on this topic a little bit, but what do you think is the biggest infrastructure challenge to enabling open science on a global scale? Jean-Claude, you mentioned governance was a big issue. Do you have any other thoughts on that? And Ryan and Anne, what are your thoughts as well?
Okay. Well, the governance is a way to make it work. It is not it is a challenge for making it work, but intrinsically the biggest challenge for global open science is having a global internet of fair data. Because it doesn't make any sense to have it only in Europe. I mean, it makes a bit of sense, but it only will be to the optimal, what you said in your conclusion. It's a global endeavor science. So if we really think open science, if we really think to move forward, then we must have a global approach to fair open data for all the sciences and a maximum of the countries.
I think there's fundamentally an incentive issue at play. I've worked with folks in many different nations for quite a few years, and one of the largest problems we run into is that people really have no incentive to actively go out and explore other infrastructure, explore other options, find out what's available, kind of outside of their sphere. And part of that's technical, but the majority of it isn't. They just don't have the funding, the time, the resources to go out and kind of crawl through all of the other options out there to find something that may be better than what's easily available to them.
I think there are, I mean, everybody always says funding and money, but I do think it's true. I saw the US implement some really amazing open data policies, and now anyone who gets a federal grant needs to make their data open per funder requirements. And compliance to this is mixed, and it's largely a resource problem because when these policies come down, there's not always, for example, an extra $20,000 in a grant budget to be able to put your data in a secure infrastructure. There's also not necessarily guidance as to where those infrastructures are and how you can use them. And I think the second major barrier is lack of international consensus around key values. Like, what are the values that we actually have around openness? And these have direct implications for infrastructure, especially if you think about things like privacy and the trade-offs between privacy and openness and information flows.
Great, thank you all. I'd like to go to the audience for questions. Does anyone have one? All right, if not, I've still got a few. So, what role do you think governments and policymakers need to play in developing open science infrastructure? And also the other side of the coin, what role do you think private and commercial companies or academic institutions have in developing them?
Okay, so Europe first. No, the role okay, this is my personal view, but we apply it in Europe. I don't think it is our role to provide infrastructure and to come up with big infrastructure plans there, because there is a lot of capacity available. There is actually abundance of capacity. Okay, supercomputing is a different question, but it is actually, if you want really to do open data science today, we don't need supercomputers for most of what we want to do. So we have the capacity, we have the infrastructures, we have the bandwidth, we have the company. So the role of for us, the role of the government is to facilitate the integration, and that's where someone needs to bring all the players together, and that's where we are. I think, at least in Europe, that's our core role. The role of the private sector is self-evident. So if you take it follows from the first point. If you assume that you don't want to create a huge infrastructure as a public enterprise somewhere yourself, it means that whatever you will do, you will have to subcontract the capacity and the provision to the private sector, and that's how it should be. But on the conditions that you determine as public research institutions, that's the whole point. So the Science Cloud is not only a service, it is also a guarantee that the results of publicly funded Europe are governed in a commons, if you want. But that doesn't exclude, of course, at all all the good providers that are there on a commercial basis, but you determine the conditions then from that perspective and not the other way around.
So I'm going to disagree slightly on a point that Jean-Claude made, in that I don't think that there's capacity, right? And for situations where there are capacity, there's certainly not commitment, because there's an impedance. The institutions that are writing checks and funding research are funding innovation. They're funding new problems and new science to be conducted. They're not making a long-term ongoing commitment to operate the digital products that come from that research. So if I have a service that the community finds value in, there's really not a line item to keep the hosting and maintenance and growth and keep updating the technology and the implementation behind it over the course of 5 or 10 years, right? And there's certainly not any line item to go back and put in another round of development or another 2 rounds of development as things change and I need to integrate with the next great piece of infrastructure. And a great example is this Open Science Cloud, right? Because they're spending an enormous amount of money to deploy this European-wide infrastructure that is open to people all over the world, but for everyone that has an existing application, for everyone that could take advantage of that, where's the funding for them to go back and re-implement their code to leverage this new resource that's coming online, right? And without that, I don't think that there is actually the capacity to sustain the research that we're funding right now.
I think that was a really interesting question with really interesting responses. So this morning, a panelist mentioned that universities don't do patents well. I think with some exceptions, such as the two panelists and the platforms that they represented, and I really do believe this, which is why I asked them to sit on this panel. Government does not do a fantastic job developing and maintaining technology, and I don't think that's necessarily the role that the government should always be playing. And I think that aside from longer term investments like the European Science Cloud, which are designed as permanent infrastructures, we should be looking to the private sector more for developing the technologies like data solutions, data collection solutions, data storage, data retrieval, the full gauntlet that can complement these investments. I think there are two challenges here, and this is mostly with my citizen science experience in mind. One of them is incentivizing and illustrating to private companies why they want to work in open science and tackling key questions like, how do you make money off of open data? Because these are uncomfortable, but they're really critical to think about if we do want to engage the private sector in a meaningful way. And along those lines, I also think that a role of government can be to clarify when it is appropriate to work with the private sector. For example, the Crowdsourcing and Citizen Science Act in the US, which our Congress passed as part of their COMPETES reauthorization, explicitly authorizes federal agencies to cooperate with private sector partners. And one important area here is, of course, technology development.
Thank you. And as a follow-up, how do you start to solve some of those capacity problems that you mentioned in terms of how do you reach out to those that want to be able to plug into these networks and use them, but don't have the funding or the time or something like that? What are some solutions, or how do you even begin to solve that problem? This is it.
Yeah, okay. Okay. I think it's a people problem. I think that the problem starts in academia. I think we need better mentoring. I think we need to pair senior researchers with junior researchers in better ways. We need to provide incentives for interdisciplinary research and interdisciplinary teams. Some of the most compelling projects that I've seen funded included a big informatics component, as well as expertise from disciplinary researchers. And then I think capacity kind of spreads out, diffused from one person to another.
Yeah, I'll echo some of that. So in the UK, there's the Software Carpentry Project, which is a great project, teaches people how to write better code, some better software engineering practices, data carpentry around how to do better data analytics. In the US, there's a Software Sustainability Institute that's kind of in a prototyping phase right now that they're looking to fund in the next couple of years to help people understand a lot of the longer term economic and community building implications of the applications that they're building. I think both of those go a long way towards building the competency and that kind of the technical maturity of the people that are otherwise just hackers and painters. In terms of the actual infrastructure component, I really believe that what they've done with the Open Science Cloud is a great idea. In that you've got to have some kind of a national identity or a pan-national identity around the infrastructure that you want to provide to the scientists to do their science. And if you don't have that, then what you've done is you've taken away the opportunity for your research community to plan for the future, right? They're constantly just taking the easiest path rather than the path that's going to give them the most longevity or the path that will result in kind of the greatest vision and broadest adoption of their work because, well, they don't know what's going to be there tomorrow. One of the the reason we had a project we were working with a few months ago, and we followed up with them a few weeks later, and we're like, hey, we're getting ready to do some reporting back to the National Science Foundation. Can you let us know why you chose to build on top of our platform? And they said, well, your funding lasted longer than ours does. Okay, we'll take it, but that's a real problem. And if there's not a cooperation between the government funders, the infrastructure they're building, and the infrastructure that your commercial providers are providing, and an understanding of where that separation of responsibility lies, then I think you're kind of undercutting the entire community that you're trying to support.
Well, when I talked about there is no scarcity in capacity, I meant technical capacity, not capability. So for what you need today in order to be able to combine disciplines, because that's actually where you will need the Science Cloud most for. These are not endless possibilities. I don't want to combine the data of CERN with your data of GBIC. So that doesn't make any sense at all, and that would create a huge capacity problem assuming you would want to do that. But for the applications you would like to do it, so the scientific application you would like to do it, what exists today technically is largely self-sufficient. I'm not saying in 10 to 15 years, but in 10 to 15 years, if Moore's law goes on, it will be solved also, so to speak. So you see, that's a difficult discussion. Now, to come back to your second question there, I personally think I mean, the previous interventions were correct, but it's a matter of priorities. I would assume that in X years' time that you simply have, if you go for a grant, you get a percentage. Imagine you're in Europe. A percentage of your grant will be earmarked as a cloud voucher or cloud coins, as we stole the idea from the NIH. Actually, we copied the idea of a trial they have there, and you say, oh, well, voila, that part of my funding, 150 billion per year public funding in Europe, that part of my funding will be used for the cloud, and then you have an incentive, then you create a supply and demand mechanism. You will create also incentives for startups to provide services to do it better, cheaper, and so on. So that's a little bit how it goes. And, I mean, I'm old. I also saw the introduction of the computer in academia. That was the last century, by the way, for those of you who So, and it was exactly the same discussion. Where are the incentives? Who's going to pay for it? Why would you do it? Where is the payback? And after 5 to 7 years' time, everyone is saying, how did we ever do it without it? And I think that it will go the same here. The advantages of going into the cloud and into the cloud services will outweigh the costs and the difficulties. And it will become a standard part of the process, of the scientific process, I think. Whereas now we see it as an additional, as an additional cost and effort.
Great. Well, thank you very much. I think that is about all the time that we have for this panel. So thank you very much to our panelists.